Cool. Hi guys. Is this all working? You can all hear me? Amazing. Cool. So yeah, we're going to be talking about CDK and team topologies. If you're at the Joel Hamilton talk, unfortunately there's a lot of copy and paste here. We just didn't cross paths and we planned these, but hey ho. Who am I? I'm Ben Pollard. I'm a service developer for Aleios. I've been working with Aleios for a year now. It's my first job, so I'm very fresh into it. And what we do is basically serverless consultancy. So we try to migrate big corporations into serverless and help startups grow from the ground up and scale quickly. So let's get into the talk. Why is it hard to scale cloud teams? I'm going to give you a very political answer and answer it with another question, which is, what do we want our cloud teams to be? Firstly, we want them to be secure, right? No matter what product you're making, you'll have some user-facing aspects to it, and you want that to be secure. You don't want any break-ins. You want your dev teams to be fast. We want quick flow and quick change and a very fast feedback loop. Stable teams, so we don't want your teams breaking, or your systems breaking all the time, and your teams having to constantly fix everything. Reactive teams, the buzzword agile, I'm sure we all love. We want our teams to be nice and agile and be able to react to change quickly, whether that is technical change or business change. We also want your teams to be autonomous. So we want our teams to basically be able to work in their independent units and not have to depend on other teams. And the only source of communication is through very specifically designed streams. And for me, the most important is we want our teams to be happy. When you have a team that's happy, you've got trust, you've got security that they're going to stay with you, you're not going to be losing people and gaining people, big org restructures. If you've got a happy team, they'll work better. I think I've learned that from my year of experience. So 2 areas that we're going to look at today to rethink is top-down security and team cognitive load. And I want to caveat this talk by saying that it's not an entirely technical talk, and we are going to look at CDK, but there's also kind of a theoretical side that comes in with the team topologies, and we try to amalgamate them both together. And we'll see how we can do that. So first things first, the top-down approach to security. Has anyone worked for a corporation where your security is up above you and enforcing the rules on you, and you develop something, you push it through, it gets reviewed by one of your developers, and then it gets through to a security team, then a compliance team, then it goes back, and then it goes back again, and you have this circle, and then you don't actually deploy that to production until month 3 or Q4 or whatever. Like it's a slow process. It causes friction between teams and internally in your own team, and it had its place when we had our internal servers, your load balancers, your VPCs when I was merely 3 years old. But with clouds and with managed infrastructure, we can kind of change this and we can reformat it and actually flip it on its side or on its back and take more of a bottom-up approach that enables the teams rather than constricts them. So essentially, enabling teams by developing security and developing tools through the platform where we allow development teams to focus solely on developing and developing the features and developing their stream of work. So that's kind of the first part of it, and we'll see how CDK can help with that. And then we also want to reduce cognitive load on teams. So cognitive load is essentially the amount that you can process at a certain time, right? So there's a limit of how much our brains can truly be processing, and if you overload that, then you don't maximize your learning, you don't maximize your efficiency to work. And these blobs on the screen are kind of a representation of that's the cognitive load that your team requires of you, and that's how much you actually have in your small little mind. And that gets too much and causes the classic thing that we all hate to see, which is burnout. And we want to change this. So we have to restructure. And when we look at cognitive loads, there are three aspects of it. There's intrinsic, extraneous and germane. I almost forgot. Intrinsic is kind of it's kind of in the name, right? It's your intrinsic knowledge, your intrinsic abilities. So something like being able to spin up a Lambda function might become intrinsic to you after you've worked with AWS for a long period of time, or just being able to write a Python function, right? Those kind of things become intrinsic to you, and you're never going to not need them. They're always going to be required in the work you do, but because they're such a small part of your processing power, we can sort of be aware of it, but mitigate it, and not have to worry too much about that. Then you've got extraneous, and that's the one that we really want to reduce. That's the stuff like your CI is failing, or every time you create a new service, you've got to update something in your CI/CD, or when you deploy, you've got to change your deployment strategy ever so slightly every time, or with SQL, you've got to add a new SQL version in, and it just causes an absolute mess. That stuff is the thing. Is the kind of processes you want to reduce. And then the most important one is germane, which begins with a G, which apparently I say wrong, but germane cognitive load, which is essentially the solving of your business domains. So that's when you've been given a direct business problem. So someone said, we need a solution to this, and your cognitive load, your germane cognitive load, is the part that is trying to solve that problem. And that's what we really want to enforce or enable in our teams to be able to do. Is focus on that germane, remove as much of that extraneous as possible, and we've got some intrinsic cognitive load that's always going to be there. So that's how we do it, and then hopefully we can fit that germane cognitive load with a bit of intrinsic into there and not have them worry about the extraneous. And it all starts with team structure. So does anyone, hands up if you know Conway's law, and we all know Conway's law, and we all know the inverse Conway maneuver, so I don't have to go too deep into it, but I'll explain it anyway for the people who don't know. So I'll read it out real quick and then just give you a second to ponder the thought if you've never seen this before. But any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. It's a bit of a slog, but have a think about that for a sec. Essentially, what Melvin Conway was trying to say was that the way that we talk to each other and the way that teams talk to each other has a direct implication on the systems that we build. And when I read this for the first time, I was so baffled by it, because I always liked the idea of people and technology and how those mix together, and this is exactly that amalgamation. And we can flip it on its side, as some of you know, and do something called the inverse Conway maneuver, where we actually design the system first and then build the organization structure around the design of the system. I saw a really good LinkedIn article just now, actually, that used the example of beers and wines. And you've got a company that sells beers and wines, and they want to create an API that allows customers to see the inventory of beers and wines. And then you've got one part of the company that's super beer, and we've got one part of the company that's super wine. So they split off and they do their own work. And then you get a beer API and a wine API. And they've both been designed completely differently because there's no communication between them. But the user who likes beer and wine now has to communicate in a different way to receive each one. Whereas if you design the system first, then you can build your organization around that. So you can say, well, actually, beers and wines are both beverages, and they both have similar properties. And so we can actually just have one team, one API to do that. So that's the inverse Conway maneuver, is designing your architecture before you design your teams. Quick note on event bridge storming. My boss, Ben Ellaby, will hate me if I didn't put this in there, because it's his article. But essentially, event bridge storming is a domain-driven design tool that helps you structure your teams and helps you find the domains through workshops, basically, post-it note workshops. I've never actually been in one, but I've seen videos and pictures of them, and I've been told about them by Ben, and they seem really awesome. And so I'd highly recommend having a read about event storming and event bridge storming, which is kind of the serverless way of doing event storming with event bridge. Has anyone read the book Team Topologies? Because if you've read the book Team Topologies, you're going to know everything that's about to come up. But that's all right, cool. If you haven't, give it a read. It's a really good book. Matthew Skelton and Manuel Pais, they do a lot of talks as well, and they are very passionate about this. And once I started reading about it, I kind of became as well. And what the book states is that, well, they define 4 teams, basically. And we'll briefly go through them. The important one for us is the platform team, but I'll quickly explain what the other ones do, so then we understand why the platform team is important. So we've got the Streamline team. They're the one that has, in the name, a stream of work, one flow of work that is their priority. So their goal could be finishing a feature or completing a feature from start to finish, or maybe just a front end, or maybe one page of a website, or maybe a custom construct or something like that. And that every other team basically is there to facilitate the Streamline team to succeed. And they work directly with the users, and they get the fastest feedback loop with them. Then we've got the enabling team. They are literally defined as a facilitating team. Their job is to support the Streamline teams as much as possible, whether that is sharing knowledge with the organization, sharing knowledge between other teams, coming up with solutions to problems before the Streamline teams have actually started implementing those problems or trying to work out those solutions. So being one step ahead of the time, that's the enabling team. A complicated subsystems team is a name which I hate because it's really hard to say. So I usually just call it the X as a service team. And if you need a particular feature which is extremely complex and you might need to input a new member into the Streamline team, instead of inputting a new member into the Streamline team and changing that team dynamic and changing the structure and how people talk to each other, you create a whole new team and you maybe 2 or 3 people to focus on that particular feature that you then deliver to the Streamline team like they're the user. So the complicated substances team becomes the development team, the Streamline team becomes the user who gives them a lot of feedback, and you kind of deliver it in APIs or however you feel necessary. And then the platform team. The platform team is the team that provides all platform, all power to all the other teams. That can come through APIs, through internal tooling, through extra security, as we'll see. And their job is to facilitate, especially the Streamline team, but also the other teams, in every way they can, and do exactly what the X as a service teams would do, where they treat this Streamline team as a user. So they'll be constantly getting feedback and new requirements to try to push the Streamline teams to help them solely focus on delivering the features or delivering their stream of work. And this is kind of how they interact with each other. Just a brief example, 3 Streamline teams with an enabling team that facilitates and shares knowledge between 2 of them, a complicated subsystems team that is providing, let's say, a face recognition engine or something that the Streamline teams wouldn't have time or the knowledge to do, providing that in an API form, and then a platform team at the bottom. Now, I want to quickly state here, the platform teams, you can have people always think you have to have one infra team or like one big platform team that kind of like holds the underlying layers of everything. Having multiple platform teams isn't a problem if it's well organized and if you understand where that platform team is, who they're interacting with and who they're communicating with and who is their end user. I think this is just a very simple example. It can go absolutely crazy, and one of the clients we have, it has gone absolutely crazy, and it's why it's not a perfect solution sometimes. And this is all enabled through technology. So let's get into some techie stuff. Does everyone know what CDK is? Yeah? Pretty much. Yeah. Joel, quick side note, mate, if you weren't here. Half of this is yours. Yeah, your slides from just earlier. So if you've been to Joel's talk, yeah, you'll see. But CDK brings basically object-oriented principles into your IAC. So you can you can do it in your TypeScript, your Python, in your classic application languages, but it also allows you to bring abstraction, encapsulation, and composition. And as a platform team, we can use all of this to help hide complexity. We can use it to help provide defaults and enforce parameters that we would think would be dangerous if we allow people to use them. Streamlined teams can then combine these personalized constructs to their own systems to then create whatever they need for their use case. And it comes in a hierarchy, L1, L2, L3, and we'll just quickly run through what each of these means and how we can use them. So L1 is your CloudFormation only. So this is in TypeScript, and it's just a simple S3 bucket. And if you see the synthesized stack, you can see that we have a S3 bucket, and the only property we have is bucket name. Essentially, it won't give you any extra parameters. It won't fill anything out for you. What you give it is what you get. And it can be really useful when you want to really, really specify exactly the parameters of your resource. It's also really useful when L2 constructs haven't been released for the particular resources you're using. So L2 constructs are curated constructs. So these are the ones that CDK provide for you, and they encapsulate the L1 constructs, but then also provide some best practice defaults and some policies. So again, we can see an S3 bucket. This time it's an L2 construct. I've added a version true. I don't remember why I did that. But as you can see, you've got the properties with the version configuration enabled. That we have set, but then we also have update replace policy and deletion policy there, which we haven't set, but they are automatically added to our S3 buckets in L2 constructs. Great thing about this as well is we can override these parameters if we want. So if we want deletion policy to be destroyed, we can overwrite it within our code. That's really useful. And then we can go one step further and have L3 constructs, which basically are CDK patterns. And if you haven't had a checkout of CDK patterns or serverless land, go have a look at it. It's really cool, and it gives you a bunch of different generic tasks that you can that have been abstracted away entirely for you to play with. So the example here is one that actually is in CDK, which you probably can't see. But essentially, it's maybe 11 or so lines of code, which will create you a API gateway, a REST API, a Lambda, and the connection between the two. So a Lambda gets triggered. And it's super simple and stops all of your codes getting messy when maybe you are making multiple API gateways or multiple Lambdas for an API, and it just gets confusing, right? So this abstracts away even more and encapsulates the previous constructs. And then we can go one step further and create L2+, which I don't know where L2+ was coined, but I'm not sure if it's the official term for it, but I think most people use it now. It's relatively mainstream. But L2+ constructs are basically the stuff that your platform team will make for you. So these are your custom constructs that the platform team create, and they can provide their own defaults, their own best practices, their own policies, and that can then enable security from the bottom up. So for example, here we can see that our bucket now can have block public access and specific encryption standard ACL. So now every time that your Streamline teams create a platform bucket, those parameters are already there, and they're automatically generated. So the Streamline teams don't have to worry about that anymore. So they can just, they think, we need a bucket, let's get a bucket. They no longer need to look at what are the security measures we have in place in our company, what do we need to add to this bucket. It's all done for them. And we can deliver it to them in published packages. So we can have them as versions. So this is just a graphic of essentially version packages. And the platform team, they'll create a package A, and then they make a change. Maybe there's a new security requirement, so they add that in and then release it as package B, which the Streamline teams can get. That's pretty much how we can deliver it to them, and that's how we can enable that. I knew that was the next slide. That's how we can enable a bottom-up approach to security. We can have the platform team at the bottom pushing the security measures and pushing all the policies through, and let the Streamline team solely focus on their development. I think Yeah, nice. And this also allows us to abstract complexity from the streamline teams. Kind of repeating myself here, where the whole point is we want our streamline teams to focus on one thing, and this is how we can get them to reduce their cognitive load so they can just focus on that germane cognitive load, that solving the business problem, and remove a lot of the complexities of security and stuff like that. And it's not a perfect solution, right? So it does help in a lot of ways to guide teams, to catch errors, to make sure that people are adhering to your security protocols. But it can be used in combination with top-down approaches. It's not that it should be used, it can be used. That's the wrong word. It's all down to your organization and your team structure and the system you're building. You have to determine, by doing things like those, like event storming workshops, and by talking to your teams, you have to determine what is the best solution for you. There is no right way, there is no wrong way. There is just a way that will work more efficiently for you, and maybe there'll be a way in 5 years that will work even more efficiently for you. So it's about working out what you need. And as much as this is a really cool solution, we should always look at top-down approaches as well. So things like service control policies, permission boundaries, control tower. We want to be able to use both bottom-up and top-down to help the teams flow. So that's it. I think that was quite quick. Sorry, maybe I've rushed through it. But yeah, CDK brings abstraction, encapsulation, all the object-oriented principles that allow us to have that bottom-up approach to security and compliance. We can structure our teams in a specific way using team topologies to help reduce that cognitive load. CDK constructs are a really natural fit, especially for microservices and for serverless when you're trying to develop at scale. And bottom-up is great, but we still need some of those top-level guardrails sometimes. But it depends on your teams. So yeah, that was the talk. I'm not a fan of questions. I'm going to say that right now. Oh, sorry. But please do find me later. I'll be around and having drinks later as well. So if you have any questions, then yeah, come have a chat with me. I'm always happy to talk. So yeah, thanks guys. Appreciate it.